Good morning, students. So today we will see what is the state and the concept related to the state equation. A modern complex system may have many inputs and many outputs. So to analyze this system, it is essential to reduce the mathematical expressions. So to understand that, we have to study the modern control theory. So to understand the modern control theory, there is few concepts we should understand. So the first definition and first concept is a state. State of system is minimal set of variable. It gives knowledge of these variables at t is equal to t0 and inputs related to t is greater than t0. So using this, we can determine the behavior of the system. And the state is unit state. We can say it is a unit in the state space. Next concept is a state variable. To represent the state, we have to represent the state. We have the one particular variable. That variable is called as a state variable, and it is indicated by the X. Next, state model. Now the points come. So what is the state model and all? So consider the system state variable as a X, input variable as a U, output variable as a Y. In the classical theory, we have the transfer function. Similarly, in the modern control theory, we should use the state model. So the number of input is represented by U of t, and then it depends on the number of inputs U1 to UM. So here the total number of inputs are the M. Then next concept is output vector. So for to design the state vector, we require the input vector, output vector, and the state vector. So output vector is y of t. So that is y1, y2 up to yp. So it indicates that in this vector, number of outputs are the p. Next important term is a state vector. So the state vector is a x of t. So x1 to xn, and the number of state variable are the n. So in this way we have the number of input, number of output, and the state variable. So design the system, the state model, we have the linear equations. So linear combination of the equations, and it is indicated by the derivative of that particular state variable. So here the first state variable derivative is equal to the linear combination of all the state variable as well as the all the input. So whatever the variable is related to the x1, it is considered here, as well as the whatever the inputs are related to the x1 is considered here, and it is multiplied by the particular constants. So like this we have the number of variables equal to number of equations, and when we compile this we will get this final equation. So it is called as a state equation. So x dot is equal to ax plus bu is it's called as a state equation. Now here what is a is called as a system matrix. So whatever the coefficient is related to the particular x is arranged into this matrix, and it should be the square matrix and depends on the number of variables. So number of variable is n, so it is a n by n matrix. Next matrix is a B matrix. So that B matrix is called as an input matrix. So B11 to Bnm is so number of state variables are the rows and the number of inputs are the columns. So mostly B vector is important and it is related to the column vector. So size of A is n, so n by n, so number of state variable, and size of B is n into m. Next equation for the state model, first equation is a state equation, next equation is an output equation into that model. Means we have to find out the relation between output, state input as well as the state variable. So the output is a y1. So the first output, again we can use the number of multiple outputs. So y1 relation with particular, see this is indicated by the x, and then relation, sorry, and it is related to the u. So in this way, when we compile this linear combination, we have the output equation cx plus du. So this is called as an output equation, and c is equal to c11. So all the combinations into this matrix, again here number of rows equal to the output and number of columns equal to the state variable. So p into m. So it mostly it is a row matrix. And D is a transmission matrix. So, here D is relation between output and input. So that combination is equal to the P into M. So the number of dimensions, D dimension is number of P. Output is output equal to the row and input is equal to M. So dimension of D depends on the output and input. Okay, thank you. Hope you understand the concept related to the state equation and the output equation. Thank you, students.